By the end of this video, I'll expect you to understand and recognize several LDS syntax errors and know how to correct them. We'll cover several rules about labels and some examples of the rule that there can be no cycles of identification dependency. This fragment is also discussed in the video about reflexive relationships. It has two relationships with no labels. This is a syntax error. There's a syntax rule that between any pair of entities there is at most one unlabeled relationship. This ensures that if we have two relationships between two entities, that they are not duplicates of each other. Each relationship on the diagram has a distinct meaning. To correct this error, ask the users what is the difference between these two relationships, and work on adding labels together. While we're on the topic of required labels, here's a fragment with a 1-1 relationship that has no label. This is a syntax error. Another rule is that all 1-1 relationships have labels. As mentioned in the earliest videos, not only are 1-1 relationships uncommon and therefore begging for documentation, but it's in particular important to distinguish between two totally different categories of 1-1 relationships, the to be and not to be. These categories are handled very differently, so we want to know if a job itself can be a task or if a job has a task, which is logically separate. Here's a fragment with a reflexive relationship with no labels. Syntax error. All reflexive relationships must be labeled. As written, it doesn't make sense to read. Reading upward, we say an object has one object, and reading it downward, we say an object has many objects. These two statements are either contradictory or confusing. Labels are required to clarify the meaning in each direction. A couple more rules about labels. Here's a relationship with only one label. That's a syntax error. A relationship has either two labels or zero labels. In many cases, you might know which way a label should read by intuition, and you might feel inclined to just write down one label for the relationship as a whole, or just label one side of it. But if you try reading this one, does the gadget supply torque to the widget, or the other way around? Highly unlikely that you can make the same statement both ways. Our goal is to communicate. Labels are meant to help us understand and prevent confusion. If you need labels, put them on both sides. Here's a relationship labeled be on one side and have on the other side. That's not allowed. A relationship is either to be or not to be. In this example, we're saying a gadget can be a widget, but that a widget cannot be a gadget. It can only have a gadget. That doesn't make logical sense. It's legal for a kind of thing to be another kind of thing and also have one of those things, but not on the same relationship. To achieve that combination, you would want to notate two separate relationships. Alright, enough about labels. Let's cover something more interesting. Have a look at this chicken and egg problem. This says that a chicken is identified by the egg it was hatched from, but it also says an egg is identified by the chicken it is laid by. We would get into an infinite loop of identification dependency to try to determine the identifier for either of these entities. So this is a syntax error. The LDS cannot contain any cycles of identification dependency. There are two special cases of this rule worth mentioning. If we tried putting a bar on a reflexive relationship, a chicken is identified by the parent chicken whose egg it was hatched from, and so on and on. That's a syntax error. No link of a reflexive relationship can contribute to an identifier. If we tried putting two bars on any one relationship, then a chicken is identified by its egg, which is identified by its chicken, and so on. So the rule is both links of a relationship cannot contribute to an identifier. We will cover many more syntax errors in future videos. For now, check your understanding of the ones we've covered so far.